All right, next up are hypovalent elements. So hypovalent is less than 8 valence electrons. And so there's two main exceptions here. There's beryllium, which only wants 2 bonds. And then there's boron and aluminum, which each only want 3 bonds. And so this may seem weird, but it does kind of make sense. Boron and beryllium are kind of right on the line of being a metal or a non-metal. And so you can think of it forming these bonds as kind of losing these electrons to become more like a noble gas. So right, beryllium kind of wants an oxidation state of +2, boron and aluminum +3. So that goes to kind of 2 and 3 bonds. So let's take a look at that. BF3, if you count the valence electrons here, you'll come up with 24 valence electrons. And so let's take a look at two possibilities of this structure. Cool. So one way we could do is just all single bonds. And then if you were to take a look at the formal charge of all of these atoms, they're 0 on all of them, right? Fluorine only wants one bond, and boron normally has 3 valence electrons. Here it's got 3 bonds, so lone pairs, so formal charge of 0. So one thing you may think about doing is moving one of these electrons here to give boron that filled octet. Let's see what happens when you do that. So when you do that, this is the structure that you would end up with. And then if you think about the formal charges here, this boron would have a negative formal charge, and then this fluorine would have a positive formal charge. And so kind of what you have here is you have a negative on the electropositive atom, or the least electronegative. And then you have a positive charge on the most electronegative atom. And so that's the reverse of what it's supposed to be. And so this is a big old no. And so in general, beryllium, only 2 bonds, boron and aluminum, 3 bonds. Later on, you'll see that these compounds are actually quite reactive as well. So in Chem 102, you'll learn about that these make good Lewis acids, which are electron pair acceptors. But that's later on in that course.